Hello guys, and welcome back again to my channel. In today's video we are going to start a new serial design. We are going to design a steel frame building warehouse, a small warehouse, and through this design I'm going to go in step by step by explaining all the different steps that we need to follow in order to perform a design calculation using SCIA Engineer. So when you open SCIA Engineering version 25, this is how the workspace look like if you do not have any project. And we are going to create a new project by going to File, New Project. This is the icon to create new project, or we can just use the command Control N, Control plus N, and we are going to start a new project. So we click File, New Project. Now we just wait for a while. When this project data pop up, we are going to define the informations. Okay, first the name of the project is a frame steel structure. You can add any description. This is the author, engineer Cedric, and the structure is not a frame. We can, in order for us to have flexibility in creating the model, we can just select a general XYZ. So it's gonna give us a 3D model. And the material that we are going to use for this structure is steel structure. It's gonna be in steel structure, and then we need to define the grade of the material. Okay, as you can see, we have different grade, 2, 3, 5, and this is based on Eurocode. But the national annex, we're not going to select any national annex. It's up to you, depending on the national annex that you want to use. For instance, you want to calculate a specific country, then you can select any specific country here according to the design. Or also, if you want to change the design code, you can click here and add an extra design code. As I mentioned in my previous video, here we have Eurocode. You can add British, you can add Sweden here, the ROS here, and then you can add the Brazilian code. But we are just going to continue with Eurocode, and we don't have any annex. We just go with the standard annex. That's all. In the functionality, this is where we try to add other. We want to add other functionality that we are going to consider in the design. For instance, maybe we're gonna do the dynamic analysis if we have brick design and all of this. But for the time being, we're just gonna leave them in the default mode. The action, we are going to define them later, because you see here the units are in feet per square meter. We are going to change the unit with metric here. We can change, and then we can select the unit. Later we can change them. And the protection would not have any protection, and that is all as the project data. After defining all these informations, now we can click on OK to define the model. The first thing to do is to define the cross section. We are going to this panel, input panel. We have a structure. We go to structure because we want to define the structure. Every time you want to define anything, you need to go in the input panel. We'll select which panel that you want to work with. We have the structure. If you want to define the structure, we have the load if you want to input the load, and we have the calculation and the result if you want to take the result. We have steel if we want to do a steel design, concrete, composite, aluminum, timber, and geotechnical. For the time being, we are just going with structure to define our structure. After that, we need to define the cross sections. How do we define the cross section? Okay, here if you do not see anything that is related to cross section, you can just go here and then in the search bar and then type cross section. You can see actually this is the icon for cross section, or Ctrl+J, and you can see it's also here, cross section. Okay, I will click here, and then I want to define the cross section that I will be using in the model. For this example, since it's a simple model, I do not have specific requirement for the cross section. I will just go with the library. I go to profile library. I select the HI or IP of the general cross section, and then I go to HE section, and then I need 200. Okay, I'm gonna go to geometric shape here. Okay, sorry. HE, I need to find some HE 200. HEA 200, yes, this is 200 ABC HE 200A. I add it. Yeah, so we have here HE 200, and I can give the name to this cross section, but this one also will define them later, but I can just click OK. The second cross section that I will need is an IPE 180 and IPE 160. These are just I'm just selecting a different cross section, and later on, if they do not meet the requirement, I can always come back and change them. IPE 180, yeah, this is it, and IPE 160. I add it. Okay, and I go again. IPE 160, it's here. Add it, and okay. Or for that, I should go to the geometry. I can just click here, and yeah, I can define them here. 70 times 70. 7. Yeah, that is okay. I think I have it. I have them close. Now I've defined. After defining all the cross section, now I need to go and define the geometry. So in order to define the geometry, we can use the geometry we can define the geometry by using the block. We have the catalog block, or we can also define the geometry based on our structure that we have defined in AutoCAD when we have all the dimensions. But for the purpose of this video, we are just going to use the catalog block. So here I need to go to catalog. Yes, catalog blocks. And then I have frame. Because I know it's a frame, it's a 2D frame. I'm going to select the first one. Okay. And then here I need to put my information. Here I can see that my units are still in feet, but I need to go back and change them first. In order to change the unit, if here is not working, because most of the time I'm clicking here and it is not working, we need to go in File, Project Setting, and then we go here in Unit Setting, and then we click on Unit Dialog, and here you just click Load User Default Setting, and then you can check. Okay, so here we can go back and check again, because this is the matrix format that is selected. And when you click on OK, yeah, it has changed. Now after that, we can continue now our design by going in catalog block. Now we have everything is in meter. We can edit this profile. We know that this height here, the length is 12 meter. This height is 5 meter. Yes, it didn't change. And this, the grabber is 1 meter. So in total we have here 6 meter. And when you finish, here also you can define directly the cross section of the column and the cross section of the beam directly. So we can just click on this, and then we know our cross section for the column is HE 200A, and for the beam is the IPE 180. So after that we click OK. But we can also click on these 2 dots so that we can give some name. We can change here and say these are the columns. These are the columns, and these are the beams. These are the columns or columns. Then what? Okay, this one can be the brace. Yeah. Once done, okay, and then here we have now we have here is column and beam IPA. Okay, when you click OK, now we need just to define the position. The location is, you can put it anywhere and later you can still adjust. Let me put it first here. Yeah, this is the frame, and when I finish I can just do Control A, I select everything, and then Control X so that I can move it, select the point and move it to 0 0. Yeah, now it's at the origin of the coordinate axis. That's how we define our first frame. The second thing, we need to multi-copy this frame in order to have the whole building or the whole structure. So how do you multi-copy? We can just go in the dialog box, write multi-copy, it's already there. And then it will ask us to select the entity that we want to copy. We select all of this, and then by clicking ESC, escape button, we want to have the number of copy is 2. Here we define the number of copy, and the distance, to define the distance by cursor, this is, we do not have the distance, but we are not going to check this one, so we're gonna just input our own distance. So each frame is spaced by 6 meters. When clicking on 6 meters and then OK, we have the frame that is defined. Now, when we finish defining the frame, we need now to define our pollens. That's gonna be the next step. Okay, after defining the frame, now we need to define the pollens. And the pollen that we're going to define are the beam. So we need to go in the working space here in the workspace, and we have one member beam and then beam. We're just gonna click on the beam here, and it's horizontal beam. We need to select the right cross section, that is the pollens, and the length here is 6 meters. But you can see the direction is not in the X direction, it's in the Y direction. So we need to change the direction. It's in the Y direction. And its insertion point is begin, or we have begin or end. So if we start here, this is the beginning of the member and this is the end. I will try to explain the both examples. But this order really matter in the software. So what is the inserting point, what is the beginning of the member, what is the end of the member. So as you can see here, we have I and J. So this is the beginning point and this is the end point. So we are starting as the beginning and we click on OK. And then we are just going to insert. We insert here. We insert here. Insert here. Yeah, when you finish, right click, you can see confirm and continue or confirm the action. If we click on confirm and continue, that means we confirm this action and we want to move to the other action. But if we confirm the action, that means we are finishing with this action. So I'm just clicking on confirm action. So the action is over. I finished with this the definition of these 6 columns. Now I still need to add one more. That is on the plan in this side, but it's still with the same dimension. And I just click here. I need to snap on the middle. This is the middle point. Yeah. And after defining these pollens, now I need to define the wall bracing or the cross bracing. I'll still go in the same option. I will input 1D member. But here the type is not a beam, it's a wall bracing. It's a wall bracing. We have roof bracing and we have wall bracing. When you define wall bracing, the software will take into account and then will assign the properties of the wall bracing to that element that you are defining. We're going to select it a standard model. we're gonna select the cross section that we have defined just right now. It is here, and we see the dimension are a bit out. Yeah. So since we changed the since we changed the units, so we've made some conversion. We need to come back and adjust them to 70. Yeah, now it's okay. Now we have the thick wall. This is 70. Yeah. So this is the cross leg that we are going to use. Yeah. And when we say okay, we can now select this point to this point, and then this point to this point. Confirm action. So this is our model, and I will also explain something. Once you define this one, there is a possibility to copy this cross bracing to the other side, the same way as we do in AutoCAD. Control C, we select the starting point. This is the first point, and then we go to the second one there, and then we are done with copying. That's all. Control. Now we need to save our model. As you know, we can save our model. It's up to you by doing Control S, and then you can define example or model 1. It's up to you. Defining the name, you can put it as you will. Because I have already steel frame analysis, I do not want to add the second name, so I just name it as I want. You can also define the name according to how you want. Yeah, so this is our model. Once you define there, and then we are done for today. Yeah, thank you for watching, and see you in the next video.